In this video, we'll be comparing individual atoms to molecules consisting of multiple atoms to solids consisting of lots of molecules. So again, a single atom, a simple molecule with a few atoms bonded together, and solids containing lots of molecules. Specifically, we're going to compare the different light that is absorbed by each. What's different about the light that each one absorbs? These things, atoms, molecules, solids, absorb different sets of wavelengths. In fact, we'll see atoms absorb the fewest number of wavelengths, and solids absorb the largest number of different wavelengths. So atoms, we said, are really picky. They don't absorb lots of light. They only absorb specific wavelengths. Those wavelengths that are absorbed, the set of wavelengths, we call the absorption spectrum, which means set. So for one atom, we said it's picky, right? We track the different wavelengths absorbed on the x-axis. The y-axis just shows how many of those photons would be absorbed. So here's why atoms are so picky. They're not very creative when it comes to absorbing light. There's only one way for them to absorb light, in fact. It's through electron excitation. So if you shine ultraviolet light, then if the wavelength is just right, then one of the electrons will be excited, will absorb that light, it'll absorb the photon, and it'll jump to a higher energy level. If you absorb blue light, a different energy transition can occur. And there's more than just the 4 energy levels I've shown, so you get more energy transitions, more light that is absorbed. Now, that's all that atoms can do. And you see that they're quite picky. They only absorb specific frequencies, specific wavelengths. And the reason is because they are limited in how they absorb light. Molecules, on the other hand, are more complex. We have now 3 atoms bonded together. And those energy levels for the electrons, they kind of mix together a little bit. And sometimes as a result, there's more energy transitions that occur, more light will be absorbed due to electron excitation. But here's the cool thing about molecules. They don't absorb light just through electronic excitation. Molecules, we've learned from chemistry, have specific shapes, and those shapes are capable of vibrating like this, up and down, back and forth. That vibration, believe it or not, is produced through absorption of light. In the same way that electrons absorb light and jump up, molecules absorb light and start vibrating, which is really cool. And we'll see how this is true another lesson. There's a range of different frequencies that the shape vibrates with. And so there's a range of photon frequencies that are absorbed. And as it turns out, we don't get visible light absorbed, producing the vibration. Infrared photons are the ones that produce the vibration, because that's the frequency that matches the vibrational frequency. Now there's one more cool thing. Molecules, they have all these tricks, these cool tricks. Not only can they vibrate, not only can their electrons be excited, but they can rotate around. And so there's different frequencies of rotation. Just the same way that molecules absorb photons and start vibrating up and down, molecules can absorb different photons and they can start rotating. Because they rotate at a range of frequencies, they absorb a range of photon frequencies, like that. So the match is perfect. If you want your molecule to vibrate with a particular frequency, you shine the exact same frequency photon on the molecule. So the frequency of vibration matches the frequency of the absorbed photon. You might be wondering, why don't we have discrete energy levels like this, or discrete wavelengths being absorbed. Why is it continuous and not discrete? Well, these are discrete, we know, and in fact, you do see discrete levels with only two atom molecules. If you get rid of the third over here and you just have two, then they are far more limited in the frequencies with which they can vibrate. And so they are far more limited in the photons they can absorb. Something like this with three molecules has enough different frequencies of vibration that it can absorb any of these possible wavelengths. Okay, now on to solids. The ideal solid is called a black body, and solids, believe it or not, absorb UV light, they absorb visible light, and they absorb infrared light. They absorb all of it. Every single frequency is absorbed by an ideal solid.